Okay, so we're going to be looking at complex numbers, and a complex number is really nothing more than an imaginary number, but it could have a real part to it. So the general form that we write is this. It's a plus bi. A and b are both real values, and I is the imaginary part. Just a reminder that I is imaginary, and that is the square root of -1. So whenever we take the square root of a negative number, we're going to have I here, and that's going to be an imaginary value. So some examples would be, 3 plus 2i, 5 minus 7i. But we could also have different combinations. So we could have 5. That's a complex number. We could have 3/4. That's a complex number. We could have 6i. That's a complex number. Any combination, we could have a complex number. In fact, if you think of any number, it's probably going to be a complex number. Complex numbers cover all the numbers that we've looked at, all the types of numbers: rational, irrational, imaginary, and that's going to be a complex number. Now, when we add and subtract complex numbers, it's going to be really straightforward. So if I have 5 plus 2i, as one complex number, and I'm going to add, well, let's say 3 plus 6i. Just like adding numbers before, adding polynomials, I combine my like terms. So 5 plus 3 is 8, and then I have 2i plus 6i, which is 6i. So my answer there is 8 plus 6i. And the same is going to be true for when we subtract. So if I have, let's do the same values, 5 plus 2i minus 3 plus 6i. Again, we have 5 minus 3, which is a -2. And then we could also have the 2i minus 6i, which is -4i. And that's going to be our solution there. So that's adding, subtracting complex numbers. Not too difficult. Multiplying complex numbers could be a little bit tricky, a little bit challenging, but again, we treat this just as we do binomials. So if I have 3 plus 4i times 6 minus 2i, if I multiply these together, then imagine these i's are x's, and we just multiply, we distribute as we would before. So this is going to be 18 minus 6i plus 24i minus 8i squared. So if I combine my like terms, 18 plus 18i. Now here's the thing. We have to pay attention to this I squared. We know that I is equal to the square root of -1. So I squared is going to be the square root of -1 squared, which is just -1. So this is minus 8 times -1, and -8 times -1 is 8. So we actually get 18 plus 18i plus 8, and we combine the 18 and 8 to 26. So we get 26 plus 18i. And notice how this falls back into that a plus bi form that we use for complex numbers. So we don't actually get something that looks like a quadratic. When you multiply complex numbers, your product will always fall back to this form. If you have an I to any power, 2, 3, 4, a million, you need to reduce that. Now for us, we're going to be just sticking with squares and other small powers, but do be aware that I squared is the same as -1. Now the last piece is if we rewrite, and so let's say I have something such as 2 plus 3i divided by 4 minus 2i. I would need to rewrite this. Now just as we did before, and if we change the I to an I squared, we change it to a real number to -1. So how do we make this I squared in the denominator real? Well, if we multiply by the conjugate The conjugate, remember, it looks like the opposite, but it's the opposite of the second term, not the first. So this would be 4 plus 2i. And if we multiply the denominator by that, we have to multiply the numerator as well. This process, while you may not have done this before with complex numbers, hopefully it looks familiar because this is the same process for rationalizing denominators. So in my numerator I have 2 plus 3i times 4 plus 2i, and my denominator I have 4 minus 2i times 4 plus 2i. Now, in the numerator, we're going to end up with 8 plus 4i plus 12i plus 6i squared. And in the denominator, this is a conjugate pair. And we multiply conjugate pairs together, we are going to get a difference of 2 squares. So 4 squared is 16. 2i squared is going to be minus 4i squared, a difference of 2 squares. If you wanted to, you can multiply this out by FOILing or any other method, but you will get 16 minus 4i squared. I just used a shortcut. Now, in this numerator, remember, I squared is negative 1. So this plus 6i squared is really minus 6. So if I have 8 minus 6, that's going to be 2. 4i plus 12i is 16i. And in my denominator, I have, again, 16 minus 4i squared, but I squared is negative 1. So this is really 16 plus 4, which is 20. Now I can rewrite this as two different fractions. So this is 2 20ths plus 16i over 20. And I reduce the fractions to get 1/10 plus, this reduces to 4/5 I. Notice this is the complex form, a plus bi. So whenever you see a complex number that looks like this fraction, we shouldn't write it like that. All complex numbers should look just like a plus bi.